In the fall of 1962, the Gama-Goat vehicle was shipped to Thailand in Southeast Asia for tests under contract with the Advanced Research Project Agency. The purpose of the tests was to determine mobility characteristics of the Gama-Goat under terrain conditions typical of those in southeastern Asia. The terrain was to include rice paddies, jungles, river crossings, and certain other types of vegetational patterns. The test program in Thailand was coordinated by the Combat Development and Test Center located in Bangkok, Thailand. 5 test courses were set up near the town of Korat in north-central Thailand. The first 3 courses had closely spaced bamboo grass combined in a moderately spaced, small-stemmed broadleaf vegetation. Test areas generally were flat, but some had strong, deep-rooted stumps and termite mounds. A test lane was staked out to guide the vehicle in as straight a path as possible and to make sure no impossible obstacles were encountered. Throughout this and subsequent tests, the vehicle was loaded to a gross vehicle weight of 5,650 pounds. The simulated payload in the rear carrier body was 2,000 pounds. Several cross-country type tests determined the following: the ability of the vehicle to continue through such an area, the ability to negotiate termite mounds, effects of the brush upon the vehicle operation, distances the vehicle operator was capable of observing, average speeds which could be maintained, and the crew and cargo protection while moving through the test area. No problems were encountered. However, unusually large trees in excess of 6 inches had to be avoided. In this test area, the Gama-Goat was subjected to thick vegetational cover and extreme changes in surface geometry. The area helped demonstrate the vehicle's articulation feature. This course consisted of intermediate to large-stemmed broadleaf vegetation, numerous trees, and tree stumps. The test area was generally flat, except for some severe ground erosion and occasional termite mounds as tall as 12 feet. Here, the Gama-Goat traversed a rough, natural, eroded area and ridge, again demonstrating the articulated design, which keeps an even wheel loading. Another purpose of the tests was to evaluate the vehicle's ability to negotiate a course 50 feet wide while taking the fastest course through the area. Knocking down of trees was held to a minimum, and no backing up was allowed. This was typical of the vehicle's operation through an unfamiliar area. This test evaluates the Gama-Goat's maneuverability and the driver's ability to see over the nose. Average speed was less than 1 mile per hour. Even though maneuverability was considered excellent, the density of the trees prevented passage without knocking some down. Throughout these tests, records were kept of all obstacles that were knocked over. Avoided objects also were noted. This test presented a problem that might be encountered on a reconnaissance mission. This is a continuation of the maneuverability test in a semi-dry area on a plateau. The test area was typical of the terrain in north-central Thailand. No vehicle traction problems were encountered at any time during this or previous tests. Occasionally, the vehicle was halted by a stump, common throughout this terrain, and standing about 20 inches above the ground. Hidden by the tall grass, the stumps necessitated sudden stops and extra care to avoid serious vehicle damage. Such rough conditions require a rugged structure on the front of the vehicle. This course was composed of extremely slippery rice paddies with 5 inches of water in some spots. Most of the area had plowed paddies with occasional pools of water and earthen walls or bunds separating the paddies. The walls had steep sides and were up to 24 inches in height. Available traction ranged from extremely poor to fair in this area, which was representative of northern Thailand during the 6 summer months. Items noted here were the Gama-Goat's ability to negotiate rice paddies and earthen bunds, the maneuverability in slippery mud, and the average speed over typical rice paddy terrain. Necessary flotation was accomplished by lowering tire pressure to 6 pounds per square inch. It should be noted that the problem here was slipperiness rather than sinkage of tires into the soil. Although some difficulties were encountered in crossing the water-covered paddies, the vehicle was never immobilized. Here, the goat climbed over a typical bund which separated the rice paddy and then proceeded through a freshly plowed and moist paddy. No problems were encountered. Average speeds, mobility characteristics, and other pertinent data were carefully recorded during the tests in the rice paddies. Courses were laid out to demand maximum vehicle flexibility and maneuverability. To test articulation characteristics, the Gama-Goat pursued several straight-line courses across the intersection of bunds and across bunds diagonally. Even though the vehicle did occasionally bottom out when crossing the bunds, traction was adequate to push across. A 15-inch ground clearance, as on the prototype vehicle, was found to be adequate for such operations. A comparison of four vehicles, the English Land Rover, the M151, the Gama-Goat, and the Japanese Nissan, was made by driving the vehicles at similar speeds over a rough road. The Gama-Goat appeared to have the best suspension characteristics and appeared to give the smoothest ride. In these scenes, the vehicle showed its ability to climb a 120% loose sand slope. Such an operation would be possible only by a vehicle with the dual-body design of the Gama-Goat. No traction problems were encountered because of the large, low-pressure tires. After completing the performance tests in Korat, the vehicle was returned to Bangkok, then shipped to Bon Phu near Bangkok for extensive trafficability tests. These tests were made in soils of varying consistency, cone indexes, moisture contents, and surface coverage, and were accomplished by driving the vehicle forward and backward in the same rut up to 50 times, or to the point where it became immobilized. All tests were carefully documented at the end of every 10 passes. This included measurements such as rut width and depth and cone index readings. The trafficability tests gave an indication of the soil types that a convoy of such vehicles could pass over if they were all moving in the same ruts. Both the cone index method of reading soils and the BEV meter mounted on a weasel vehicle were utilized. Trafficability tests were run in soil that varied from less than one allowable pass to over 50 passes. This helped determine the exact number of passes that could be made in any one type of soil by this type vehicle. In general, results were extremely good. As concluded, the Gama-Goat possesses the best trafficability characteristics of any existing vehicle with standard type tires. The prototype was equipped with a 12.4 by 16 tire with a tread not well adapted to this type of work. In this area, the water level was only 4 to 6 inches below the surface of the soil. Test results indicated that the vehicle had the ability to make one pass in such soil with a cone index of approximately 15. The BEV meter gathered soil data throughout the test series. The differences in ground consistencies are shown. At the far end, there was very little rut depth, and in the foreground, the rut depth became increasingly deeper. On the inside of each rut were the points at which the suspension arms began to get into the soil as the vehicle approached bottoming out. This scene shows the typical point of failure in the trafficability study. The vehicle sank into the ground until it was completely bottomed out. Both the suspension members and the bottom of the vehicle rested on the ground, and the vehicle was unable to move. The utilization of an aggressive tread probably would have aided when traction became the limiting factor. In this test, the vehicle stuck after starting on the 40th pass. The cone index was 38, and the vehicle had its entire undercarriage resting on the ground. This was in the mud flat area, only 200 yards from the ocean at high tide, with the water level approximately 4 inches below the surface. The fact that the goat showed slight articulation between the front and rear bodies indicated soil condition changes within a relatively small area. The bellying out of the vehicle and the area over which suspension arms were dragged is shown here. There was no excessive slippage as the goat went through. In these scenes, the vehicle is making high-speed runs over brush-covered mud flats close to the ocean. Speeds in excess of 20 miles per hour were obtained. However, six-wheel drive was necessary to get sufficient traction. Although slipperiness was encountered, undue sinkage did not occur. After the trafficability test at Banpu, the vehicle was shipped to Lopburi, Thailand, where articulation and slope tests were accomplished. This slope test up a natural dirt and rock-covered slope at an average grade of approximately 55%, with one area near the top at 75%. The vehicle was able to completely traverse the slope. The limited slip-type differentials prevented any excessive wheel slip as the wheels passed over large rocks, sometimes 3 or 4 inches in diameter. It was possible to start the vehicle on the slope, continue upward whenever desired, and back down with complete control. Test operations were then transferred to a rock-covered quarry to determine the value of articulated design. The large underbody clearance, as well as the goat's articulation feature, permitted passage over terrain which would ordinarily stop wheeled vehicles. The value of articulation and limited slip differentials is demonstrated in this climb over an extreme ledge. Here also, in terrain common to Thailand, the Gama-Goat's articulated design, low gear ratio, and ease of driving facilitated operations by all drivers. Here, the vehicle broke over to the design limit. The vehicle's maximum breakover angle was approached with the center wheels off the ground and the nose dug into the soil. The condition was caused by a boulder in front of the machine. No danger was involved, even though the vehicle was broken over so that the brake drums on the center axle encountered the rear body. This type of slope represented the maximum capability for the Gama-Goat. There was no damage encountered during the test, and the vehicle proceeded to the next condition. Additional tests were made in the rice paddies to determine the maximum acceptable speed without damage to the vehicle. Results of these runs, made with and without men in the rear body, were carefully evaluated. The vehicle, with a propeller attached, was then driven into one of the klongs or canals. Water crossings such as this are quite common in Thailand because of the canals scattered throughout the country. Some problems in getting the vehicle out of the water were encountered due to the extremely wet, slippery mud on the bank. However, the vehicle was able to winch itself out and proceed without further problems. Winching undoubtedly would be required on many canal crossings with the standard wheeled vehicle. Gama-Goat drawbar tests were performed in the area near Bangkok at Banpu. The tests, using the Trackmaster vehicle as a towed load vehicle, were made at full rated payload. Recording instruments were carried in the rear body, where an operator monitored the test information. The fifth wheel determined vehicle speed, and a load cell was attached between the Gama-Goat and the Trackmaster to determine actual drawbar pull in pounds. Examples of data recorded are moisture content, rut width, rut depth, and the soil cone index. Approximately 63 tests run at this location were monitored by Thai Army personnel. Soil data was obtained by a BEV meter located in the rear vehicle. During all drawbar tests, variables included tire pressure, soil conditions, including cone index and moisture content, engine RPM, and traction aids. Chains also were used during some of the tests. Drawbar pulls of 3,600 pounds were obtained at this site, where soil cone indexes ranged from 51 to 118. Here, the rut depth and soil cone index are being measured. Following the drawbar tests, the vehicle was driven to the Pronbury Military Reservation in southern Thailand, where trail performance and additional tests were conducted. The jungle trail chosen for the runs extended about 21 miles into a dense, uninhabited portion of the Thailand jungle. This was a typical location for the drawbar tests, on a plateau under a typical jungle canopy. The goat also was tested on 10% and 20% slopes composed of grass-covered sandy loam. River egress tests were performed on the extremely loose, sandy bank of a river. The slopes were near 60% and sometimes greater. Certain difficulties were encountered when the goat returned to land after flotation, since the sand did not allow sufficient traction for placing additional wheels on firm footing. Virtually any type vehicle would have met similar problems in climbing up the loose bank. One of the two major tests conducted on the jungle trail consisted of a moderate speed run to establish fuel consumption. The other test was a similar run to determine the maximum average speed over the rough, winding course. Over a 7-mile section, the vehicle recorded an average speed of 10.9 miles per hour with fuel consumption of 4.7 miles per gallon. Mud holes and washed areas helped evaluate mobility characteristics. Throughout testing, United States Army personnel drove the goat to obtain their impressions of performance and maneuverability. The Thailand Jungle Trail, considered a severe test of performance for Southeastern Asia, provided rugged test grounds for the Gama-Goat. The vehicle never became immobilized and traversed all heavy rutted sections. At Lopburi in north-central Thailand, rice paddy drawbar tests and suspension load tests were performed. The rice paddies had a plowed surface and a cone index ranging from 64 to 116. Here, a maximum drawbar pull of 4,800 pounds and wheel G-loads above 6.0 were recorded. As mentioned earlier, Thai soldiers operated the Gama-Goat during tests and also during demonstrations for the United States and Thailand armies. Men who were completely unfamiliar with the vehicle were able to operate it successfully after a 1-minute briefing. The easy transition to driving the goat again demonstrates its versatility and the valuable function to be performed for the Army in the rugged terrain of Thailand.
Minimizes body contact in extremely rough terrain. The maintainability and reliability of the truck during the grueling Army test program of over 250,000 miles was excellent. The Gama-Goat is outstanding in soft soil performance. Its capability by way of its articulated motion and independent suspension, plus a low ground pressure, enable it to travel in soils that previously had been limited to low ground pressure track-laying vehicles. To demonstrate this ability, the vehicle climbed a 20% slope that had been prepared to 13 inches of mud. The limited slip differential also adds to its tractability when changes in soil conditions are encountered. Its superior soft soil performance also applies to snow and sand. Controllability in snow and on icy roads is significantly enhanced by its four-wheel steering. The outstanding tractive effort of the vehicle enables it to travel through heavy wooded terrain. The outstanding drawbar pull weight ratio enables the Gama-Goat to tow loads up to 9,000 pounds. Tests were conducted with the 5,500-pound 105-millimeter howitzer over all types of terrain. The tests, while towing the howitzer, included negotiating a 50% dirt slope with a full 2,500-pound payload in the rear body. The lightweight sealed aluminum construction of the Gama-Goat provides a swimming capability. The vehicle will swim at speeds up to 2.5 miles per hour by movement of the wheels alone. The swimming stability and free board of the fully loaded Gama-Goat has been verified by operation in water. Its ability to enter and exit inland waters over unprepared banks has been proven in extensive tests. The Gama-Goat can be transported and delivered from marine craft in beach landing tactical operations. It can negotiate breakers when the surfing kit is added to increase freeboard at the tractor. Over-the-beach operation is enhanced by the all-wheel drive mode, also used when negotiating in the water. Entrance and exit angles and all-wheel drive allow the vehicle to be reloaded into transport craft during water operation in either the forward or backing direction with adequate control. Army tests have included a soft landing in the C-130 aircraft and transport in the C-130 and CH-47 helicopter. No preparation is required for external helicopter lift. One truck was utilized for airdrop testing at Fort Bragg, North Carolina. The 7 required drops were completed successfully, and the Gama-Goat was driven off the airdrop pallet after each test. The frontline ambulance version of the Gama-Goat M792 has provisions for 3 litter patients, 1 medical attendant, and medical equipment. A rear body heater is provided to permit ambulance operation in Arctic areas. The United States Army program has included also tests with kits which were developed concurrently with the vehicle. These kits were tested in the same severe environment as the basic vehicle test. The S-250 shelter kit provides an all-weather enclosure for communication equipment and other electrical and electronic equipment, such as acquisition radar. This shelter can also be used for command posts or fire direction centers. The Gama-Goat transports a 4.2-inch mortar kit, 25 rounds of ammunition, plus a crew of 4 men. It also carries the 81mm mortar, ammunition, and crew. An original requirement was that the Gama-Goat carry and provide a firing platform for the 106mm recoilless rifle. As a result of the high profile, this requirement for firing from the vehicle was deleted. A kit is now provided for transporting the rifle and ammunition. However, it is fired externally on a ground mount. Provisions are incorporated for 35 combinations of general-purpose radios. Provisions are also included for 6 antenna locations. The 7.62mm M60 machine gun kit is located on the right side of the tractor. The gun is immediately available for use in the event of ambush, and this location provides excellent traversing, elevation, and deflection characteristics. The Gama-Goat will operate in all areas of the world. Its versatility, utility and maintainability, mobility and operating economy have been proven in tests in all environments. The Gama-Goat is in keeping with the Army's desire to provide the fighting soldier with the best and most advanced equipment possible to accomplish tactical objectives.